Hello, thanks, Kevin. My name is Tilde. I use they, them pronouns. I am a senior developer educator at LaunchDarkly, and today we're going to talk about social justice and prompt engineering because large language models have so much promise, so much potential, and yet they have inherited all of our human flaws because they're trained on human data. So what do we do? Well, there's actually a lot of researchers actively digging into this right now, and I'm excited to share their findings with you. So I'll cover one paper from industry, one from academic, and kind of go into how do we apply these, and then summarize the takeaways for you. So let's go. The first paper I'm going to talk about is from Anthropic in December 2023. Now, there's no real scientific consensus on how to audit an algorithm for bias, so these researchers have taken a page from social scientists' book. A popular way for social scientists to study bias in hiring is correspondence experiments, where they would take the same exact resume, put two different names on it, names where you could infer a race and a gender from the name, and send it out into the field and see who is more likely to get a call back. Now, if you were going to do a correspondence experiment on a large language model, instead of sending in a resume, you would send it a prompt and similarly put in names. Now, these researchers were investigating whether Claude 2.0 showed bias when asked to make yes or no high-stakes decisions about hypothetical human beings. And their first point, which I cannot underscore enough, is that you should not use large language models to make high-stakes decisions about human beings. Not yet. They are not ready for that. So they used the model to come up with a list of topics, and then each topic got a prompt. In this example, it is about, should we hire a person with this qualifications? And then they put the demographic data, which in this case is a 30-year-old white female, directly in the prompt. Now, all these prompts were designed so that a yes response was a positive outcome for the hypothetical human being in question. The researchers tested both putting in the demographic data directly, as you saw there, or using a name that could be associated with the race or a gender. Now, the results of this study actually surprised me, which is that Claude showed positive discrimination. It was more likely to give a yes response to women or non-white people. However, Claude showed negative age discrimination against folks over 60 years old. So the researchers tried modifying their prompts by adding statements, really don't discriminate, really, really don't discriminate, really, 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 really don't discriminate. They also tried some more variations, like saying affirmative action should not affect your decision, instructing the model to ignore any demographic information, reminding the model that discrimination is illegal, and a combination of those last two factors, which turned out to be the winner. If you look at this chart, the bright yellow is a combination of reminding the model that discrimination is illegal and telling it to ignore demographic characteristics, and that dropped bias the most out of everything that they tried. Some limitations of this study is that it does not consider every possible vector of discrimination, like size, gender identity, religion, all that good stuff. And it does not account for intersectionality, which is the idea that if you're a member of multiply marginalized groups, bias is multiplicative, not additive. And I cannot mention intersectionality without giving credit to Kimberly Crenshaw, the brilliant theorist who invented the term. So the next paper comes from Princeton University. Now raise your hand if you've heard of an implicit association test. Some of you probably have, if you've ever taken unconscious bias training at your company. So these tests were developed for humans to understand the biases that we are ourselves not even aware of. And these researchers came up with a way to give implicit bias tests to large language models, which is pretty cool because I don't work at OpenAI. I don't have access to proprietary closed source data, but I do have access to the output. So these researchers asked the models to associate words into categories, and this is very similar to how you do this for a human. In this prompt, the model was asked to choose between white or black for the following list of words and write their choice after each word. So if you associated, I don't know, axe and grenade with black, you might be showing implicit racism, which unfortunately all of the models that were tested did. So they showed high levels of stereotypical bias. So then the next question becomes, does this bias actually impact how these models make decisions? And for that, the researchers wrote another round of prompts that had the potential to be discriminatory but weren't blatantly so. In this prompt, they were asked to generate 2 short profiles about black and white preschoolers who lived in different neighborhoods, and they were each supposed to draw one concept, painful or joyful. Who should pick what? Now, all these models showed bias in their decision making, but the good news is it was an order of magnitude less than the implicit bias shown in the previous round of testing. And what these researchers found was that asking the models to make explicit, absolute decisions, yes or no, led to less bias than relative decisions like choose one candidate over the other, which might explain Anthropic's results because those were extremely absolute. So these researchers also tried adding a clause saying treat people from different socioeconomic statuses, et cetera, equally, and that dropped the bias in GPT-4 almost in half. And this is a finding that seems to be a pattern. It was replicated in one other paper that I can find. So the combination of telling models to ignore demographic information seems to be the winner. Now, I'm going to show you how to apply this to a real-life prompt. One other paper that I found that I really liked was about writing reference letters. And I think this is a really cool and interesting use case because people are using models to write letters of reference today, and I don't think that's a bad thing. So if you ask a large language model to write a letter of reference, it can show gender bias, emphasizing women's personality traits more and men's achievements. But these researchers, the prompt that they used is shown here, and it's not very detailed or specific, and they didn't try to modify it at all, so I think we can do better. Now, I ran this prompt through GPT-4o Mini with some names, Brad and Lakeisha, and the results that it gave me out of the gate were not too bad, but it still emphasized Brad's outstanding academic performance and Lakeisha's leadership skills. So in order to make this better, I'm going to add more relevant contextual information, like the student's GPA and their extracurricular activities. And I'm going to instruct the model to ignore any demographic information and remind it that, hey, it's important to treat everybody equally. So when we do this, the results that we get are much more equivalent. Now, if you want to run head-to-head tests of different models and different prompts, I work at a company called LaunchDarkly, which is a developer-first feature management and experimentation platform. And our AI flags make it super easy to test models and prompts against one another, and you can find out more information at the QR code there. But just to summarize what we have learned today, if you take away one thing, do not use large language models to make high-stakes decisions about human beings, and if your company is telling you to do that, you need to push back. For unbiased prompt engineering, remind the model that discrimination is illegal and tell it to ignore demographic characteristics. Tell it to make absolute rather than relative decisions if you can, and anchor your prompts with relevant external data, like when we passed in the GPA to the letter of reference. Architectural patterns like RAG can be really helpful with that. And blinding also isn't that effective because just like human beings, large language models can infer demographics from things like your zip code or where you went to college, so it's hard to truly mask that data. Now, prompts are very sensitive to small changes in wording, and new models are coming out at such a rapid pace it's really hard to keep up. So you're going to want to build flexibility into your architectural systems and the ability to keep testing and iterating. Now, thank you so much. Here's where you can find some slides with more detailed references. Here's where you can find me on social media, or just find me during the break. I would love to chat with you. Thank you.